For some years now, I have had this tabletop flattener. It's a manual process to flatten the tabletops, but the tabletops I have been flattening with this has been very okay. So I was just thinking all the dust, all the mess of dust in the air, and you have to wear a mask. And you have to use the time to do the flattening yourself. Why not rebuild this to a CNC controlled machine instead, and then let a computer do all the flattening, and then I can just lean back and drink a cup of coffee and enjoy the work the machine is doing. And as you can see, it's a very simple construction. It's built on some aluminium rails, and it moves in two directions. The height for the tabletop, or the surface of the tabletop, is set on the router itself. And as you can see here, a lot of chips, and they produce a lot of dust. So in the same time, I will try to make a kind of dust extraction, so all the dust from the tabletop flattening will, so to speak, disappear from the room. First thing to do is to split the assembly in parts and see how many of the parts I can reuse. I want to reuse as many as possible to keep it simple in the beginning, and then the machine must evolve from there. The base is on the MDF reinforced tabletop, an old one, and I have mounted the rails, the main rails for the Y-axis on four corners, so I can kind of adjust it to run through when I want to adjust the machine. As control board, I have chosen a cheap Chinese board here. It's a copy of the Planet CNC Mark 1, I think it is. It has a lot of good functions, so I think this will be my base in the beginning anyway, and I will probably look into some other boards going forward, but this will be my starting point. For the stepper driver, I have chosen TB6600. They are also some cheap Chinese drivers. They're very common. I'm not sure they are the best in the long run, but for a start they can do. And the stepper motors is also some Chinese motors, NEMA 23. I think the size of these steppers will be okay, at least in the beginning. I can always test and see if I have enough momentum on the force, and if I'm not having what I need, I of course need to update them as well. The layout of the electronics is done in a cheap plastic box, and the main purpose for this is just to keep the dust in the area from the electronics when the machine hopefully start working at some point or some time. It's mounted on some plywood. This is not best practice, but for now it will do because I just need this up running, and then I will change that later. The wiring from the stepper drivers to the stepper motors, I have chosen just to use some wiring I have in my workshop. It's normal recommended to use shielded cables, but I want to test and challenge that a little and see how much trouble it actually will bring me. Because there's a lot of screw terminals in this project, I have chosen to crimp all the ends of the wiring to keep a good and solid connection. So this is the final layout wiring. And if you look at the left, you can see a power supply that supply power for the controller board, the stepper drivers, and of course also for the stepper motors. And in the lower left corner you have for the spindle, it's a cheap Chinese 400 watt that has been bought for another project actually, but I will use it here in the first place to get some experience with the spindle and the machine when it's up running. For the mechanical part of the construction, I'm not going into details showing how to drill holes and cut pieces and stuff like that. I have tried to reuse as much as possible, as also stated earlier in the video. As you can see here, the way the gantry has been built, I used 5mm plate of aluminium here, and the rail, the main rail, and the wheel that is running in the main rail is not in a V-groove as normal used. This is just a simple one for, I think it's for a door sliding, something like that. But it seems to work okay. And you can also see I'm using a belt here. I'm using a GT3. So this is how it ended up. And I haven't done the wiring here, so that will be in the next. And then for the wiring, I need to have a kind of cable chain guide here. So it has to be mounted in this area somehow. I need to figure that out. And of course, I also need to have all the wires distributed inside the cable tray. And here you can see a picture of the GC3 belt I'm using. And for the belt tightener, I just used my 3D printer to print some parts here. It's very easy to use the 3D printer, and this is how it ended up. And a quick tour around the gantry, one of the side here, and here you can see how the plastic part actually ended up, and also you can see the construction for the x-axis here, how also the z-axis has been built, also from parts from the original flattener. So I was trying to reuse as much as possible. Maybe not the best, but this is how it turned out. And then there was some work with all the wires. I had to cut the wires in the right length and figure out how the wires should be distributed so they were running in the right places and to the right stepper motors and stuff like that. It took a while to do the wiring. I'm not going to show anything from that work. I'll just show the final result. After the final wiring, it was time to do some tests. And as you can see here, the x-axis worked fine. The y-axis I did have some small trouble because it was running with 2 motors and the controller board could not combine 2 channels. So I needed to do some small tricks here, but it came up run anyway in the end. And also the z-axis was working, so that was great. So then it was time to look into the spindle. I added the wiring for the spindle, and then I was testing the spindle as well to see if I could remote that, start and stop, and it also worked fine. After everything has been set up, it was time to test. And I'm not running fast here in the first attempt. I don't want to stress the system yet. I can always try that later. But it seems to work okay. And it took about, after 25 minutes, something like that, it finalized the text here, the engraving. And yeah, it didn't go fast, but I was more interested to see that it finalized it. And here's the final result, and it actually turned out to be pretty okay seen from my eye. The next test is doing an inlay and then surfacing the inlay here to see how it actually fits. It's to look into the precision, to figure out how precise is it when I'm doing a plot and the pocket and put them together with glue. And you can see here the result, and the result seems to be okay. It's very simple inlay, but still it's a fine little test. If you go a little closer here, you can probably also see that it's not 100% because it is not what we call a V-carve inlay. And here another test with a 90 degrees V-bit. And also a test for the alignment of the x-axis and y-axis. I'm using a surfacing router bit to do this. And again, I'm not running fast. This is how fast it is. And I know, yes, it's not the correct speed. It should move much faster, but I just want to see how precise the setup is. And then I can always work with the speed and feed later. Looking into the result from this cut here, you can see that there are some circles. indicating that something is not, yeah, let's call it stable. The cutting is not optimal here. It should be smooth, but it's not. And the reason might be that if I kind of, you can see dragging a little or pushing a little here, it's not rigid. It's a little wobbling, and it seems to be enough to do something here with the alignment and the way it's working. It's also wobbling in more than one direction. But for now, it has to be as it is. And instead, I will focus a little on the dust collection. I have bought this dust, what do you call dust collection shoe, something like that. It's bought on Amazon, and it is fit, or it should fit directly on this kind of spindle with the size. I was planning to do something myself, 3D printing, whatever, but I realized the price tag for this one was so cheap that I just bought that instead. So the main purpose is to get rid of the dust, and yeah, then I bought this one. And as you can see, it's just compatible right away. You just press it on, and then you can use an Allen key to tie it to the spindle. And the bottom, or the shoe, what you call it, is very simple and very easy to put on, because you have these two magnets that will keep it in place. If I try put in a bit here, you can also try see how easy it is to mount and unmount when you have the bit. And again, you can see here it's very simple, very easy. And another thing I like is the transparency. I think it's very good, because then you can probably see what's going on when all the dust is sucked out from the area where the V-bead is working. To make the vacuum and suck all the dust and chips out, I use my DeWalt. It's a DeWalt M class, so it is also for fine dust. Now it's time to have a test to figure out if there are any suction and if it works. And when I held my hand below, it feels like it's working very well. So after some tests with the same text, you can see here that the result is actually pretty similar. I'm not running fast, not here in the beginning. The reason is I just want to see if it works and how precise is the machine. And in this case also see how much dust actually are collected or removed from the work. So I'm actually pretty okay with this, and I think I will try move on and do some more tests. But as you can see here, the Z-axis is not that good, and even though I try to use some of the old spare parts or some of the parts from the previous machine, the spindle here is actually hanging in the ball bearings in the stepper motor, so it's not that good. I need to figure out to update and make this better. So I might as well just start dismantle all this. I need to look into the Z-axis, figure out a new way to build the Z-axis so it will be more stable and more precise, more solid. And to do that, I need a new plan. And in the same time, I think I will also just buy a new spindle and put on a new spindle. This spindle here is a little too weak. So thank you for watching and have a nice day.